Hello everyone. In this lesson, let's see problems associated with sine, cosine and tangent ratios. So the sine, cosine and tangent are known as the three primary trigonometric ratios. Now let's look at the formulas associated with each of these ratios. Let's say we have a right triangle. The angle here is 90 degree and then the longest side of a right triangle is known as hypotenuse. And we must know that there are two acute angles in this right triangle. So one of acute angle is this one and the another is this one. Let's say the acute angle here is theta. So with respect to this theta, the side length that is far end to this theta is known as opposite. And then the side length that is just next to this theta is known as adjacent. So now the formula would be sine of theta will be opposite over hypotenuse, and cosine of theta will be the ratio of adjacent over hypotenuse, and then the ratio of tangent of theta will be opposite over adjacent. Let me demonstrate this once more. So let's say we have a right triangle. The angle here is 90 degree and then the longest side of a right triangle is known as hypotenuse, and let's denote it by h. And let's say the acute angle here is theta. So the side length that is far end to this theta is known as opposite, and let us denote it by O. The side length that is just next to this angle theta is known as adjacent, and let's denote it by A. So now sine theta will be opposite over hypotenuse. Likewise, cosine of theta will be adjacent over hypotenuse. And tangent of theta will be the ratio of opposite over adjacent. So to remember these formulas, we have one memory aid called SOHCAHTOA, which is SOHCAHTOA. So this means that sine is the ratio of opposite over hypotenuse, cosine is the ratio of adjacent over hypotenuse, while tangent is the ratio of opposite over adjacent. Now let's look at this problem, which says that determine the ratio of sine, cosine and tangent for angle theta in the triangle below. So we have this angle theta here, and with respect to this angle theta, the side length that is far end is known as opposite. So opposite here is equals to 3. And then the side length that is just next to this angle is known as adjacent, which is equals to 4 in this case. And then the longest side, which is hypotenuse in this case, is 5. So sine of theta is equals to opposite over hypotenuse. Opposite in this case is 3 and hypotenuse is 5. So 3 over 5 is equals to 0.6. And cosine of theta is equals to adjacent over hypotenuse. So adjacent in this case is 4 and hypotenuse is 5, which equals 0.8. Then the tan theta is equals to opposite over adjacent. Opposite in this case is 3 and adjacent is 4. So 3 over 4 equals 0.75. Let's look at this another problem, which says that determine the ratio of sine, cosine and tangent for angle theta in the triangle below. So in this right triangle, the length of the two legs are already given, which are 8 and 6, but the length of hypotenuse is not given. And since we are asked to find the ratio of sine and cosine, it's important that we find the length of hypotenuse before we find the ratio. So now since this is a right triangle, so we can apply Pythagorean Theorem to find the length of the hypotenuse. So let this be A, let this be B, and let this be C. Now the Pythagorean Theorem says A square plus B square is equals to C square. A square means 80 square, b square means 6 square, and c square is as it is. 8 square is 64, 6 square is 36 equals to c square. 64 plus 36 would be 100, which is equals to c square. Now on this side, we just want the value of c, and we want to remove this exponent of 2. So to do so, put square root on both sides of the equation. So the square root of 100 equals to the square root of c square. Now this exponent 2 and square root get cancelled out, which just leave us with c on this side, and on this side the square root of 100 will be 10. So the length of the hypotenuse is 10. Now with respect to this theta, the side length that is far end, which is 8, is opposite in this case. The side length that is just next to it, that is 6, is adjacent, and then of course the longest side hypotenuse is equals to 10. Sine theta is given by opposite over hypotenuse. Opposite is equals to 8, hypotenuse is equals to 10. So 8 over 10 equals 0.8. The cosine of theta is given by adjacent over hypotenuse. Adjacent in this case is 6, and hypotenuse in this case is 10, which gives us 0.6. Likewise, tangent of theta is given by opposite over adjacent. Opposite in this case is 8, adjacent in this case is 6, which is approximately equals to 1.33. Now let's look at this another problem, which says that determine the cosine of angle A in the triangle below. So in this problem, we are asked to find the ratio of cosine A, cosine of angle A, which is given by adjacent over hypotenuse. And in this case, the hypotenuse is already given, that is 13, but the adjacent to this angle A, which is this side length, is not given, and we are also given with this opposite side length, which is 12. So before we find the ratio of cosine A, we need to find the length of adjacent by applying Pythagorean theorem, since this is a right triangle. So let's say that this is A, and let this side length be B, and let this side length be C. Now the Pythagorean theorem says that A square plus B square should be equals to C square. So A square means 12 square, B square is as it is, and C square means 13 square. So 12 square means 144, B square is as it is, 13 square will be 169. Now on this side, we just want the value of B. So we need to remove this 144 from this side of the equation. To do so, subtract 144 on both sides of the equation. So 144 minus 144 plus B square equals to 169 minus 144. So now 144 minus 144 is 0, so B square equals 25. Now on this side, we just want the value of B, and we want to remove this exponent of 2. To remove this, put square root on both sides of the equation. So square root of B square equals to the square root of 25. So B equals square root of 25 equals to 5. So the length of the adjacent here is 5. Substitute in the formula. So adjacent in this case is 5, and hypotenuse equals to 13. And 5 over 13 is approximately equals to 0.38. Now let's look at this problem, which says that find the acute angle in H. In this case, the ratio of sine theta is already given, which is 0.5. So this 0.5 means opposite over hypotenuse. So the ratio is already given, and what we are asked is to find this angle. Sine theta equals to 0.5. Now theta equals to, take the sine on the other side. When you do so, it will be sine inverse. When you take it on the other side, it will be inverse. So sine inverse of 0.5. And to perform this in your calculator, you can press shift plus sine of 0.5, which gives us 30 degree. Make sure your calculator is in degree mode rather than in radian or gradient form, because we are finding this angle in terms of degrees. So make sure you set your calculator to degree mode before you perform this calculation. Now let's find the theta for question B, which says tan theta equals to 1. Since we are already given the ratio of tan theta, that is, this 1 would be the ratio of opposite over adjacent. So theta equals to, take this tan on the other side and it will be tan inverse. So when you take it on the other side, it will be inverse. So tan inverse of 1. And to perform this in calculator, shift plus tan of 1, which will give you 45 degree. Now let's look at this another problem which says that find angle A in the triangle below. So now we are asked to find this angle. So how is this angle? Is this 30 degrees? Is this 45 degrees? Is this 60 degree? So that's what we are asked to find. So now with respect to this angle, side length, that is far end, is known as opposite. So opposite is equals to 3 in this case. And then the side length that is just next to this angle theta would be your adjacent, that is 4 in this case. Now the trigonometric ratios that involves the side length opposite and adjacent is tangent. So I can say that tan of theta equals to opposite over adjacent. So tan theta will be opposite in this case is 3 over adjacent is 4, which is 0.75. So the ratio of tan theta is 0.75. But we are not just asked to find this ratio, but rather we are asked to find this angle. So to find this angle, take the tan on the other side. So theta equals to tan inverse of 0.75, which will be approximately equals to 36.86 degree. So the angle here is 36.86 degree. Now let's look at this interesting fact on sine and cosine. Sine 0 degree equals 0. Sine 20 degree equals 0.34. Sine 30 degree equals 0.5. Sine 45 degree equals 0.7. Sine 60 degree equals 0.86. Sine 90 degree equals 1. So when you go from 0 to 90 degree, the ratio of sine increases from 0 to 1. So now let's see in case of cosine. Cosine 0 degree is 1, cosine 20 degree is 0.98, cosine 30 is 0.86, cosine 45 equals 0.7, cosine 60 degree equals 0.5, cosine of 90 degree equals 0. So when you go from 0 to 90 degree, the ratio of cosine decreases from 1 to 0. I hope this lesson is helpful.